Okay. Lesson today is about logarithm. How many of you have heard about logarithm? Logarithm. You heard of it? Okay. So about 5 or 6. Okay. So logarithm. It's just a backword of exponential. Yeah, exponential. You can think about a square, cube. Okay. Last time we learned about exponential, right? How do you convert this one? A to the power 1/3 is a cube. Huh? Yeah, that's right. But how do you convert this? What does it mean? The 1/3. What does it mean? What does it mean of the power 1/3? Cube root, right? Cube root. Remember the one inside, the 3 outside, and this one is 2. So 2 form, radical form, and exponential form. All right. So today we're gonna learn exponential form and log form, logarithm form. So 2 cube is 8. Now I'm gonna convert into the log. Okay. And we tell you how to convert it. It's this. Oh, now it's like fancy, right? Now you feel like your map level is increased, like advanced, because now you can understand what is log. You've seen it before, but you never understand what is this. So here we go. The concept is this. If I give you any number b to the power a equal to c, let's use different color so you can know what's going on. A to the power b to the power a equal to c. If I want to convert this, ready? Just write down what I'm gonna do together, all together. So I call this snail method. You know the snail? Yeah? Snail method. Why snail method? You will see. This snail method, smiley way, is came from me and my mentor. So if you heard someone know this one, that means it's our students. It's original. Okay, ready? So snail method is this. You want to convert to the log, right? So start with here, and you go to here. So you start with the b. The b is going to be go first. Okay. Snail method is just showing you the order of the number b, and then you go to the c. So this is c, and then you go back to here to the a equal to a. Your cluster equal sign equal to a. This is the order. That's showing you the order. Now, why is it snail's method? Does it look like snail method? Does it look like snail? Yeah. So you kind of make like the body of the snail. Now, if I give you the log, you can also use in the snail method to come back to this one. That's quite interesting. Now look at this one. Okay. I'm starting with the b as well. Okay. That's why b go first. Yeah, you following? I go into it here. That's why I have the power a. The order it go in order. B to the power a, b to the power a, and then I come back to c, and now equal to c. It's still the next method, right? So it's showing you in the beginning. You need this. In the beginning, you're gonna need this snail method to showing you where's the order. But the more you work with this, you will understand. You don't even need a snail. Okay. For example, if I don't give you this number 3, okay, if I don't give you this number 3, this is the question you should ask yourself. Like if I ask you what is this, you're gonna ask yourself, 2 to what power is 8? That's what you should ask. Okay. But we're gonna do the power and we're gonna do the assemble. So don't worry. This is 3, right? Let's do assemble. Assemble 1. Okay. What is log? 3, 9. 3, 2. So again, you're gonna ask yourself, what did you ask? 3 to 3 to what power? To what power is 9? Okay, that's what you should ask. 3 to what power is 9? 3. So it's the same thing with the Snell method. 3 to what power is 9? Because that's the way of the order, right? 2 to the power 3 is 8. Snell method, right? So 2 to the power 3 is 8. Same thing here. 3 to what power is 9? So 3 to what power is 9? 2. The answer is 2. That's the log. That's the meaning of log. Log is just the reverse of exponential, of taking the power. Okay? Make sense? Okay. So convert. So direction. That's the basically that's the what we're gonna do today. That's the concept. Now we just do an example. That's why today let's say it's going to be short because it's not a lot. So convert between exponential and log form. Okay. So this one is they call, this is log form, and this one is exponential form. Okay, so let me consistent with the color. So B is blue, C is green. Okay. All right. So this is symbol 1, symbol 2. Can you convert that into log? So let's write a log. Okay. Log. What number go first? Oh, I forgot to. How do you read this? I forgot to say, how do we read this? How do we read this? Log 2A3? No. So how do they know what's going on? You're gonna say this. Did you see that I wrote this one like very lower, right? This is the base. Okay. So B right here is the base. It's very, you cannot write at the same level. You need to write like small like this. Okay. So this is read log base 2 of 8. Log base 2 of 8. Okay, that's how you read it. Okay. Log base 2 of 8. And then how do you read this one in general? Log base B of C. Okay. All right, everyone, let's read this one. Log base. Very good. The way you say the way you read it is also showing you like how do you understand this. If you say it wrong, people they can't know, right? So that's why writing and speaking is very important because they know where's your standing, what is your level. All right, how did you convert this? You start with the 4, right? So log 4, log base 4, and then you go to the 64. So 64 is a big number. And then equal to, now you go back to the 3, equal to 3. That's how you convert this. Easy? Easy. Let me ask you this one first before you convert. What is log 5 of 5? 100? 125? Who else? Who else have all the answer? 0. Addison? 1. So we have 125, we have 0, we have 1. What is this? So what is the answer? 1. See, you're gonna ask yourself. You're gonna ask 5 to what power is 5? And the answer is 1. Right? Good. Let's give there's some point. So Allison, Jose, what do you say? Did Nico say something? Anything? He said 0. So wrong. So get 1 point off then. Yeah, let's give Nico, right? Something. And Ernesto earlier. Okay, Nico, convert this one. 5 to the power 1 is 5. That's how you convert it. Good job. So 5, go to 1, come back to 5. So 5 to the power 1 equal to 5. Okay? Easy? Based on this, we're gonna write later on. We're gonna write some notes about the log. Okay? Log, they have a lot of properties. Not a lot, like 8 properties. We're gonna learn today maybe like 3 or 4, and then next time we're gonna learn about another 4. Okay? This is one of them. Later on, we will erase this and we're gonna write the property. But let's work all of them first. Let's see what happened. What is 2 to negative 1? Negative 2? 1/2. Okay? How do you convert that into log? Raise your hand, get some point. Naila? Log. First, you start with a log, right? Log base 2. Very good. 1/2. Very good. Equal to negative 1. Good job. 1 point to Naila. So notice this 2, okay? We're going to talk about this 2. So can I erase this? Yeah. Number 5. Log of 36, 6. Ooh, what is this? Ooh. So you're gonna ask yourself, 36 to what power is 6, right? So 36 to what power is 6? What is that? Huh? 1/2? Yeah, I heard a lot of 1/2. Why 1/2? Because 1/2, what does it mean of 1/2? Square root, right? So square root of 36 is 6. Yeah. So you can have the negative when you see the fraction. But if you want to go like the base number is bigger than the number here, then you think about a fraction, okay? Because a fraction means you're gonna take in the radical. Now let's go easy. Go back to the easy. Huh? You the hard one? Coming up, coming up. Easy. What is this? 1. Now you get used to it because 7 to the power 1 is 7. Okay, log 1 over 4 negative 1. Oh, 4. Three, 4. 16. 16 over 16. Who else? Any other answer? So you're gonna ask yourself, 1/4 to what power is 4? Okay, 1/4 to what power is going to be 4? 4? 1/4 to the power of 4 is 4. 1/4 to the power of 16 is 4. 1/4 to what power is 4? It is. Because I want you everybody to think about this. -1, right? Think about this at one point. -1, because when you see the -1, you flip it. So 1/4 to the power -1. So the answer is -1. It's similar to this. Do you see that? This one is 2, and you get 1/2. 2 to the power -1, you get 1/2. Now this one is just 1/4. You get a -1, you get 4. They fraction. They flip it. Okay. So you're gonna write a note about this one too. Let's just write the last one for this part. We have 3 parts. This is first part. Oh, this is part 1. Okay. Part 1. My bad. We have 3 parts. That's why it's very short. 3 part. But easy stuff like this. Now let me ask you this. Okay, just raise your hand if you know the answer. Okay. What is log? No, let me make it more fun. 129 maybe. Yeah, 129. Log base 129 of 1. Just raise your hand if you know the answer. You have 1. You have 2, 3, 4, 5, 6. Good. Now Dante, what is that? Oh, guys, I love you. Like, oh yeah, that's right. Now look at this. 129 to what power is 1? 0. Everything to the power of 0 is 1, right? This is also one of the property we're gonna write down later, because 129 to the power of 0 is 1. That's a good introduction. All right, can I erase this? I'm gonna keep this too. All right, so write a note. Note. Okay, whenever you see log b of b, take a look on the 8th example we just did. When you see log b of b, what is it equal to? 1. When you have the same number, you can think about it cancel out. Like this. You can think about cancel out. Okay? And then also later we will see that b log b on the top like this. Let's say we have some x, okay? B log b like this, it also cancel out. It will not really cancel out, but when you work through it, you will see that this one just gone. And that equals to x. Whatever you have left is there. Okay? We will see this one later. Now second, if you see log b of 1 over b, also equal to log b log 1 over b of b. What is it equal to? When you see they are flipped, they are reverse of each other. -1, because the power negative, they're gonna flip them. They're gonna reverse, right? So they will be equal to -1. And then what else? If you see log b of 1, they always equal to 0, because everything to the power 0 is 1. And when you see the base larger than the number, think about fraction. Think about a fraction, because fraction means you take in the radical. Number 1, yeah. The second one here. So later on, you will see something like this on part 2. So maybe you will see on part 2. When you see log b and b, they cancel out. When you see the log b and b, they cancel out. Okay. But this one you cannot have like this, because you're missing the big number. So that's why I just put a symbol. If they have x, this one cancel out. You have left the x. They will be always cancel out. You think about like this. Think about cancel out. Okay. You will see that on a part 2. All right. Maybe leave some 5 lines. Okay. Leave 5 lines. Leave 5 lines. I tell you to leave 5 lines. Don't write down. Leave 5 lines. Okay. They tell you about story of the teacher and student. They answer ASAP, ASAP. This period. So the professors email to the student say that, oh, you need to email me as ASAP, ASAP, right, as soon as possible, right? To make up your test. Hurry up. And then the student answer ASAP. Because the teacher say, email me ASAP. So the student email back ASAP. You know what is it? You know what I mean? Use your brain, people. Yeah, use your brain. Leave file line, leave file line, leave file line. Don't write down, okay? Because we're gonna update the note right here, the property. So this is the log property. Log property. Okay. Okay. So then I'm gonna write over here. Part 2. Oh, we actually can do both. Yeah, we actually can do both though. Okay. So on the calculator, some old calculator, they don't have the base. If you take a look on the log here, do you see that they only have log? They only they only have log, right? Oh, the video is here. You can check review, or you can just open your YouTube and look at it. So the log is here, right? They don't have the base. They don't have this one. They don't have something for you to input the base, unless you get like scientific calculator or something. So they only have log. On a calculator, they only have log. So that means base. Who know this already? Invisible 10. Okay. If you don't see the log, if you don't see the number, the log by itself is invisible 10. Log of base 10. Log base 10. So let me ask you this. So what is log 100? 10? Gerson? Really? 2. Right? Why? Okay. Log, there's no base. There's no base. That means invisible 10, right? Now ask yourself again, 10 to what power is 100? 2. Okay, so invisible 10. So on the calculator, the old one right here, they don't have the base. They only have log. And you need to later, if you want to find some on the base, you need to using the chain of base formula. That's going to be 9e. Oh, that's commercial time. To be coming up 9e. Chain of base formula. That's how you're gonna find the base. That is not 10. Okay. And then you also see ln. ln. Oh, actually, you know what? Let's not talk about ln. I want too much information. We're gonna talk about ln on 9c. That's why I decided to start this one first. Okay, so direction for this part is evaluate without calculator. Evaluate logarithm without calculator. Without a calculator. Easy though. Oh, let's give Arely and Gerson 1 point. They got number answer very fast. Number 9. Easy. We only did this. Layla. What is it equal to? Yeah. 4 to what power is 64? 3. Did we already did example, right? Who want to answer this? I want to give a shot. All right, Jose. Huh? -1? -5? Naila? -5? Gerson? -2. Let's give Gerson 1 point. If you contribute, you get point anyway. Let's give Jose and Obed 2. Yeah, Naila 2. Why? Okay, why? Because 5 to the power -2. Oh, -2. If you want to make it positive, you need to flip them, right? So 1 over -2 become +2. And then 5 to the power 2 is 25. So that's 125. Okay? And log 5 of 0.2. Without using calculator. What is this? Raise your hand, raise your hand. Anyone else? Anyone else? New people, new people? Listen. Why -1? So 0.2, if you don't know how to convert it, you can think about this. 0.2 is 2 to power 2 over 10. Do you know you divide by 10, you move the decimal place, right? You're right? So 2 times 100 is 200. Or 2 divided by 100, that means you move decimal place to 2 times. So 0.02. So 0.2 is 2 divided by 10. And if you simplify it, you're going to have 1 over 5. If you don't know immediately, 0.2 is 1 over 5. Okay, so this is 1 over 5. And 5 to what power is 1 over 5? We're going to talk about this. 1, 5, 5, and 1 over 5 is -1. Right? Let's give Edison 1 point. Raise your hand, raise your hand. Okay? Anyone new? Still 2 of you? Nala? Okay. Dana? Arali? All right, Julie, Melissa? Melissa? Huh? -5? Ernesto? -3. 5 to the power 3 is 5 to the power 3 is 125. And now you want to flip them, right? Same thing as number 2 here. See that? 1 over b and b, right? So as long as you see the fraction, you know that that's going to be negative. 5 to the power 3 is 125. So 1 over 5 to the power 3 is 1 over 25, right? And now you want it to be 125, not 1 over 25, you put a negative. So -3 is 125. The thing about negative, we're going to put top to bottom of bottom to top. So now 5 cubed is 125, but not 5, it's 1 over 5. Then just put a negative, that's it. 5 cubed is 125, but it's 1 over 5. Put another negative, that's it. Okay? Let's give Melissa 1 point. Arali 2, right? Yeah, Arali 2. If you contribute, you get point. Did you say something too, Dana? No, right? Did she? Okay, Dana 1 point too. All right. Raise your hand if you get the answer. Oh, give Ernesto last time. I forgot. Oh, Nico. Okay, Nico. 1. Nyla? -2? Why -2? Okay, good. So log, no base, that's be invisible. 10, right? So you're going to ask yourself, 10 to what power is 0.01? All right, 0.01. You need to know what is that. That's mean 1 over 100, right? 1 over 100. Okay? So again, if you see some fraction, that means you need to have some negatives going on. There's some negatives going on there. And that is, okay, 10 squared is 100. But now you want a fraction. So you're going to be -2. Very good. They give Nala 1 point. Great job. And you master the log now? Yeah? All right, part 3. Last part. So simplify expression. Then can we also do the 9c? But so that means I'm gonna cut a lot of homework. How about that? Yeah, make a deal. Is it easy? Easy stuff. 9c also very easy. So just combine them, and then we're gonna cut a lot of homework. Okay? Forgot. Why is it equal to? If you pay attention, you can know how to do this one. What is it equal to? Yx. This is right there, right? Or right here. When you see log b of b, or you see b to the power log b, they all cancel out. So think about this one. They're gonna cancel out. Log a and a cancel out as well, and you have left x. Okay. Phi to the power log phi of 2x equal to 2x. You just cancel this out. 2x. All right. How about this? Just raise your hand. Okay. Don't say the answer. Just raise your hand. Anyone? All right. Nesto. 2 to the power x. Nyla. 2x. Obed. 2x. Why 2x? 5 times 2, 25? Say it again. Say it again. I know what's going on, but the way you say it is not correct. 5. 5 to the power 2. Okay. 5 to the power 2. All right. Good. Okay. Let's give Ernesto, Anela, and Obed. Good. So 5. Well, this one, when they have the same number, you can cancel out, right? This one, they not the same number yet. But can you manipulate this? Yes, like they just did. 25 is 5 square. So x is still there. That means you're going to multiply with the x, right? Yeah. So 2x, and then now you can cancel the phi and phi. Log phi and phi, and you have 2x. Good. Good job. Well done. Yeah, hold on. Sure. Easy though. So easy. Yeah, hold on. What is it equal to? Easy. 2x plus 1, that's it, right? Too good to be true. You can cancel it. You have 2x plus 1. No, you didn't get this? Okay, how about this? What is it equal to? 7? Yeah? Alright, 7. 7. If you think 7. Okay, you think it's not 7. don't fall into the trap, okay? Don't fall into the trap. Does that look like this? Does that look like this? No. This one you need to use in calculator. I mean, this one is some number, but they're not equal to 7. Only 7 when the log is the power. Okay. Only this one is 7, but this one is multiplication. So you need to use in the calculator. Okay. But they're not equal to 7. They're not equal to 7. Okay. Only this equals 7. So be careful here. Okay. I put it as a trap. A trap. Huh? Oh, just put on calculator. Now we're gonna do the 9C. No, no. Now we start 9C. Yeah. So we done the part 3. This is the last one for the part 3, and then that's the 9D. Go to 9C. I'm gonna make it short, and then also cut the homework for you. Okay. Okay. So 9C is about natural log. Okay. That's another type of log. It's just a special type of log. But before we learning about the natural log, we need to know the E. So introduction of E. Introduce new irrational number. Irrational number. Welcome to the family E. How many of you have heard about E? It's yeah, I saw it on alphabet. I saw it in my name, like Ernesto, right? What is E? Exponential. Yeah, but okay. So, but what is E though? You know what the number is E? So E is just some special number, like pi. What is pi? 3.14 something, right? So E is also some special number. E is approximate 2.712 something something. It's just some special number. 182. 182. And how do you call E? What is the real name? Euler number. Euler number. Euler. 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 We just say Euler. Euler. Euler number. Euler. Now you make me dub by myself. Euler. Yeah, Euler. Euler number. That's how you read it. Euler number. Euler. Euler. What is Euler? Euler is the name of the person. It's a mathematician. Yeah, long it's ancient time. So you did see the poster, greatest mathematician all time. So that's Euler is there. Yeah. So he found this number. So that's why we call Euler number. Okay. Pi is I think Euclid or Galilei or something. Oh, Archimedes. The Eureka, the Eureka. You know Eureka? Archimedes. Archimedes, right? How you say his name? The chemistry, yeah. Eureka. You know the story? Did you take chemistry? The one that taking a shower in a bathtub and then he found a no? Eureka. Eureka. Archimedes. You know him? No? You, yeah, his friend. Is your friend? Chemistry. If you take chemistry, you should know him. So, but he the one invent the pie. I mean, not invent, but he found a pie. Because you answer some people, yeah. He found a pie, and then Euler found this. Huh? Pi. Do you know what's the meaning of pi? Pi is the ratio between the circumference of the circle with the diameter. Yeah, that number is fixed. So that's how they found it. They found that there always some certain ratio between the circumference and diameter, and that number is for all circle. Anyway, why we go to the pi? Oh, we talk about the e. The e. Okay, now. So part one. Part one. Simplify expression. If you see like this, how you simplify this? This is old stuff. This is old stuff. Where is it go to? Treat, okay. Treat E as a variable. Okay. In here, you can treat E as a variable. So multiply the number together. 2 times 6 is 12. And then what is E to the power negative 3 times E to the power 5? E2, yeah. That's it. Exponential property, right? Same thing as x to the power negative 3 times x to the power 5 is x squared. So same thing. So that's why I'm saying here, you treat E as a variable, as an x. Why is that equal to? Multiply the number together. 2 times 3 is 6. Now what do you have? Y. You add them all, right? There's no division. So you can just, because they're all multiplication. So you can just add all of them. So y minus 2y plus 2, which is e to the power 0. Y minus 2y plus 2 is, what is y minus 2y plus 2? Just negative y? Negative y plus 2, right? Or you can put 2 on the front, because we don't want the negative on the front. So 2 minus y. Why is this? They make the x and the power more fun. That's fine. Okay, e to the power 4 over e is e to the power 4 over e is e3. You subtract the power, right? Remember this lesson 6a, the very first lesson when you come back to the school on the screen. So e to the power 3 x, everything to the power 2 outside. What you gonna do with the power 2? You distribute it, right? Distribute everything, every single thing. So 3 square. Now 2 and 3, are you going to add them or multiply them? Multiply. Distribute. The word distribute also means multiply. So 3 times 2, e to the power 6, and x to the power 2. Let's simplify a little bit. 3 square is 9. That's it. Part 2. Okay, let's get a calculator. Let's get a calculator. So I'm going to show you how. I mean, we should practice how to use in calculator. Okay, so let's start with something easy first. E to the power 4. Do you find it? Where's the E is? Where's the E? Do you know where's the E? Ln, but then the E is in the purple, right? That means you need to press the second, and then you press the Ln. See that? Yeah? You need to press the second and press the Ln. Did you know where's the power is? Power 4. How do you do that? It's automatically there. Okay, so then just press 4 then. What did you get? 54.59. Okay, maybe three decimals is good. Yeah. E to the power 1/3. Any other answer? Any other answer? What did you get? Did you get the same thing? Gabriela? You get the same thing? Second, Ln, and then 1/3 divided by 3. Divided 3. Close it. Yes. Good. You need to close the parentheses, okay? So like when you press on the calculator, they give you this one, right? And you need to close the parentheses. All right, so the answer is going to be 1.3956. You can round up if you want. It doesn't matter. Okay. Now e to the power -2/3. Syntax error. That's what he said. How many of you got a syntax error? Okay. So the reason you have the syntax error because you're using this negative here, right? You need to using this negative right here. Okay? This right here. This is the negative. If you press this one, it's going to be syntax error. Okay? So what did you get? 0.5134 something. Okay? Number 4 e to the power 0.5 times e to the power 2.6. Number 4, 0.5 e to the power 2.6. What did you get? Any answer? Huh? Did you get the same thing? Same thing? What you get? How you got that? Yeah. What did you press? You got 10 to the power. You need to press the Okay, so the answer is 6.7319 something. Okay. Log 27 square. Do you see the log? The log is above the ln. Good. What is log of 27 square? 2.863, right? If you round it up, it's going to be 3. Yeah? Yeah. Huh? How do you get that one? You need to grow. Oh, yeah. If you put a dot, that means they found all the log first and they squared later. So the 27 square, okay? Do you need calculator for this? No, right? Log, invisible, invisible 10, right? Invisible 10, so 10 and 10 they cancel out. The answer is 3. Now, okay, there are two different things. If you I want to emphasize, if you make it incorrectly on a calculator. For this question right here, if you don't have the parenthesis, right? This one is 27 square. They square first, and they're gonna do the log. So if you don't do the parenthesis and you just press like this, like I just do right here, they automatically have the parenthesis here, right? And you square like this. They're gonna give you a different answer. It's gonna be the 0.48. Why? Because what they do over here is they're gonna take the log first. They take the log first, and whatever the answer is, they're gonna square later. That's gonna be wrong. Okay? You need to close the parenthesis between the 7 and square to let them know that to let the calculator know that you need to square first, and then you take the log. Make sense? Okay. All right. So part 3, right? Part 3. All right. Now on the calculator, do you see the ln? Yeah. So right, natural log. If you see on a calculator, you see ln. Okay. What is ln? Natural log. Okay. ln is the natural log. Now, but what is the ln though? ln is the log base e. Okay. Natural log is the log base e. Just, so that's why I want to teach that after you learn about a log. Okay. So what is lne? What is lne? What is the natural log of e? Huh? What is the natural log of e? Don't try calculator. Don't try calculator. Just, what is ln? Is log e. Right? ln natural log is log base e. Do you agree? We just learned this. So ln e, that's been log base e of e, which is 1. So ln e is 1. Okay, natural log of e is 1. What is this? What is e to the ln 7? What is e to the ln 7? No idea. You just know that ln is a log base e. That's nothing special. E ln is what? Ln is log base e. 7. Do you see the same thing? Do you see the same thing? Cancel out, right? E to the power log e, b to the power log b, cancel out. Answer is 7. Yeah? So ln and e they cancel out. That's it. No. Part 4. 6 part. 6 part, but only 2 and 3 like this. See? Part 3 only 2. So convert. What is the number of the sample? 6. All right, how do you solve for x here? So if you don't know how to solve it, you know convert it. Okay? Can you convert that into the log form? You start from here, right? Snell method, you start from here, you go to let's write log first. Log, you start from here. So log base e, you go to the 3, log base e of 3 equal to x. That's your answer. X equal to this. You can find this on calculator, right? Now, this is not quite finished yet because log base e is ln. So that means x equal to ln3. Just use calculator. So it's about, you can also using calculator to check it. It's about 1.98. 1.986 or 1.0986. Make sense? Any question? Okay, let me explain again then. E to the power x is 3. You want to solve for x. It is not obvious. It is not clear how you solve for x here. So then you're going to convert them into the log. The lesson we just learned like in beginning, the 9D, right? Snell method, you remember? Log, you start from the e. You go to the 3, so e, and then you go to the 3. And then you come back to the x equal to x. So what's good here? You convert it here, right? Now, we just learned that log base e is actually ln. It's just a short way to write natural log. Okay? So I replace this whole log e by ln. So that means x equal to ln3. X equal to ln3. I just rearrange to write up on the left. That's it. That, did you solve for x? Yeah. You get the x by itself. Did you know what is this? Yeah. We can use calculator. ln3, just press on the ln3 on the calculator, you got 1.986. Make sense? Yeah. Just convert it. Just convert it. Why is this? Convert it. Convert it, right? You're gonna convert it. Snell method, you start from the, what number you start from? 7. Start from 7, you write 7. And then you go over here. So 7 to the, how do you write 2? 2 is the power, right? The power. 2 is the power. So go to the 2 equal to x. Oh, so x equal to 7 square. What is 7 square? 49. So x equal to 49. Snell method. Yeah? Easy? A little bit harder, a little bit, right? Snell method, right? Just using next method to convert it. All right, number 9. How about this? $1,000. Very good. That's it. 1,000. That because they're invisible 10. Yes. So you want to convert it, right? You want to convert this. This is a log. This is the same thing as the log base 10 x equal to 3. So convert by using the Snell method. 10 to the power 3 equal to x. Oh, that means x equal to 10 to the power 3 is 1,000. Yeah. So just convert them back and forth so that they can solve you what is the x. Log 3x equal to 3. Oh, easy. You don't need to using anything. You can just answer right away. X equal to 1. You need to understand what the log mean. This to the power this will be equal to this. Remember the question you asked yourself? 3 to what power equal to this? So now the x is right here. Now ask yourself, 3 to this power will be equal to this. So x is 27. If you cannot, okay, if you cannot see it clearly, you can just do the Snell method. So that means is 3 to the power 3, right? 3 to the power 3 equal to x. So x equal to 27. What I meant is sometimes you can just answer it right away. So make sure you time in and time out of it. When you leave, you need to check out the time. Okay? Did you leave for 2 hours already? The 15 minutes maximum, the law. Okay? If you over maximum, over the 15, you need to stay after school to make up the time. That's the rule. All right, log x of 16 equal to 4. Sometimes you can do the math in your head. You don't need to even convert it. What? Okay, x, right? X to the power 4 equal to 16. What is x then? 2. You see that? What? So log, this is how log works. This base right here to the power of this will be equal to big number right here. Okay? So x to the power 4 equal to 16. What is x? X is 2. If you cannot see it obviously, then you can convert it. Convert it. X to the power 4 equal to 16. So x equal to 2. Huh? -2. Okay. What is this? What is this? Mm-hmm. No. Yeah, you're missing that part. What is the ln? All right, ln. Okay, what this problem is? Ln is log base e. X equal to -2. So what is that? What is x? If you cannot see it right away, you can just convert it. E to the power -2 equal to x. So x equal to 1 over e squared. You can also just do this. Make sense? Okay. All right, last part, number 5, right? Part number 4. Five? Five. Yeah, six part, but I'm gonna skip one because we only done a lot. Save the best for last because that is also on the homework, so we should talk about it. Number 13, y equal to 2. Easy though, easy though. You learn how to wrap the exponential function already, right? That's the lesson 9A or 9B. You just did. This is also the exponential function. This is also exponential function. Okay, what is domain and range here? Domain is everything. Negative infinity to positive infinity. Range. Any any thought? All right, so domain is this easy. How about range? Do you remember the exponential function we just did last lessons? Right? Do you see any addition or subtraction? No. So that means where is the HA? HA is at 0, right? Right? Is it above 0 or below 0? They're always above, right? So from the bottom to the top, they always start from 0 and above it, right? So do they cut the 0? Do they touch the 0? Never touch, right? What is the HA? What is the definition of HA? Can someone remind us? What is the definition of HA? Horizontal asymptote. What is the definition? The graph get closer and closer, but never touch, right? It's like you and your A plus. Ah, just kidding. Well, because we don't have A plus here in the school. That's what I meant. Uh-huh. No, that's what I say because they never touch. They never touch. So you're above the 0, but you're not equal to 0. Not equal to 0, that's why this one is parenthesis, not bracket. Not the range and domain, okay? What number? What number? 0? Huh? -1? You want to make this, remember, you want to make this one to become what are three number? Last lesson. Last lesson. -1, 0, and 1. You got the 0 ready. How did you make this one become -1? -2. -2 times 1/2 is -1, right? So -2. How did you make this one become 1? 2. So when you plug it in, you're going to have 2 times e to -1, right? That means 2 divided by e. And this one is just 2 because e to the power 0 is 1, so 2. And this one is e, 2 times e to the power 1. So just 2e. So using calculator, you can find what is the exactly value of this. 2 times e. Oh, how do you find 2e? Use calculator. How you find 2e? How do you find 2e? or 2 divided by e. How? Huh? Okay, let me see. Let me see first. No, don't. Yeah. No, using the e, not the number. Okay. How do you put this one on calculator to calculate 2 times e? Let me see. Yep. Let's give bonus 1 point. How do you write it on calculator? The calculator, they always come with the power, right? When you press E, they automatically have the power. But if you only want the E, that means the power is invincible. 10. 1. So 2 times E to the power 1. Again, because the calculator, when you press E, they automatically have the power sign. You need to put some power. So that in this case, you're going to put the power is 1. So what is 2E? What is 2E then? 5.4, about 5.4, right? How about 2 divided by E? 0.74, right? You round it up, it's 0.74. So then you can plug it in. So negative 2, 0.74 right here. 0, 2, 0, 2 right here. And then 2 and 5.4 up here. That's your graph. We only learn how to graph it. It doesn't take you that long. .74. Just 2 more, okay? Just two more sample. It's very fast. We can, and then that's it. Good job today. I'm gonna skip you a lot. All right. What is the domain here, though? What is the domain here? Domain is always all real number in negative infinity to positive infinity. Now the range. How do you know the range? The range come from. Oh, we need to write it down. Otherwise, we're gonna take one off. Okay. HAY equal to 0 here. So that's the range. Okay, let's write a note then. The range come from HA. Okay, range come from HA. What is the HA here? Y equal to 1. Is that above 1 or less than 1? Okay, so if you're not sure, if you don't know yet, just do the T table first, and then you're going to answer that back later. If you're not sure, okay? Now, what number so that the power going to be negative 1? 1, right? 1 plug it in negative 1. What number of the x so that the power going to be 0? 0. What number so that the power going to be 1? Negative 1. Now, plug it in, you have 1 half e to negative 1 plus 1. That means 1 over 2 to the e plus 1. So the negative power is not negative number. Remember that, okay? The negative power is just a fraction. So now can you answer the range already? Is that above the 1 or below the 1? You know what I mean? So HA is y equal to 1, right? This one, y equal to 1. This one going to help you to find the range. My question is the graph going to be above the range? Above the y equal to 1 or below the y equal to 1? Below or above? You still not know? E to whatever power is still positive. Keep that in mind. Okay, because e is a positive number. So if you take any power of the e, you still get positive number. They're always positive number. In fact, they're always larger than 1. Right? So how do you answer the range? How do you answer the range? Anyone? How did I answer the range over here? They're always above the HA. So it starts from 0 to infinity. Now, this one is you go from 1 to infinity. Also parenthesis because we don't touch the HA. Make sense? Okay, now just calculate. Can someone calculate for me? 1 divided by 2e plus 1. So 1/2 plus 2 is 3/2. This one 1.5. What is this? Huh? Oh, you talk about time? What is calculation here? I thought you talk about a calculation. Can someone help me calculate this? 1 divided by 2e, everything plus 1. No. Be careful on calculation, okay? So you're gonna press 1 divided by open parenthesis 2 times, yeah, 1 point something. 1.1839. Yes. You need to have 2 parentheses. Let me see. So 1 divided by open parenthesis 2 times e, right? 2e, e to the power 1. You need to close one parenthesis for the 1 and close another one for the 2e. And then you plus 1. Okay? E to the power 1 divided by 2 plus 1. That's going to give you about 2.35. Okay? All right, let's plug it in. 1.8 something here, 0, 1.5 above here, and then negative 1, 2 point something here. Okay, that's it.